Yes, good evening. I think we have stopped the drip irrigation yesterday at some point of time. We try to continue and then finish this drip irrigation in this video. Let us go back to our presentation earlier. Uh, so, in the drip irrigation, we have covered much of these things like what is the definition, and then we have stopped at some kind of emitters. I think we have to cover the emitters. We have came here filter in the drip irrigation. Yeah, we are now for emitters are being covered now. So let us see how the emitters are working. Emitters in the drip irrigation. Drip nozzles, commonly called emitters or drippers, are provided at regular intervals on the laterals. So it all depends upon the kind of crop you have. They allow the water to meet at a very low rates, usually called in trickles. It's a drop by drop. It trickles. So it trickles. Hence the name drip irrigation. Since a drop by drop it comes, so it is called a drip irrigation. There are three general types of trickles. One is water seeps out continuously along the lateral line. Already we have seen along the lateral line continuously water gets seeped through various holes and all that arrangement. Another one is water drips from the emitter or spitter. This is also called spitter. Not only emitter, it is also called dripper, emitter, spitter. They are all synonyms. So these emitters connected to this line will be simply they are inserted into the line, to the lateral, and then they simply drips the water. Then another thing is water sprays or drips from holes punched in the lateral. This is also directly a hole is punched at particular point where the plant is there, where the trees are there. So in order to get more water, in fact, we said bigger trees are also fed with this kind of feeded with this kind of drip irrigation. So the discharge rate of emitters usually range from 2 to 10, even bigger. In fact, if the tree is big, so many liters per hour, depending on the pressure at the nozzle. So this is very important. The pressure at the nozzle is very important ultimately. The components of the nozzle could be made from PVC block powder by means of dies and plastic molding machine. This basically these drippers are made by molding machine. You can see here various kinds of drippers. Normally this is the kind of dripper we see when we visit the very nearest one is the grape gardens in Hyderabad. Most of you can visit here. Usual dripper, this is the thing. There are other drippers also. So these are the various kinds of drippers. So now we talk about design of drip irrigation. There are various items in here to discuss. For example, one is a water source, another one is types of crops, another one is topographic condition, and then soil, and then climate. All these things, information you must collect before you design. Normally, this drip irrigation is adopted in a water scarcity regions. Therefore, the source is not a big thing. This either a small well or a tank, or even rainfall can be stored during the rainy season, and then that can be utilized for the drip irrigation. This is one important concept, particularly those areas where the no water source either through well or even through a canal. The rainfall can be stored. The runoff from the rainfall can be stored, but it has to be filtered properly because the drip nozzles get clogged. That is very important. So even the well water also to be filtered. There is no doubt. That is why filter plays a very important. So if you don't care about the filtering, then you will have a lot of problems in the future. Okay. So then the types of crops. Normally, what will happen in drip irrigation? You should have a row types of crops. Row pattern should be there. You cannot have a very spreading type, because every plant we are exactly watering at the root zone of the plant. So that is why you have necessarily the row pattern should be there. But again, this row pattern, it can be something like a curved in a straight line or even a circular. So that does not matter. But the crop should be a row pattern. The general layout of the system, especially the emitters, will depend on the type of the crop. That already we have shown in the very first slide. It may be a circular one, it may be a line, and so on. Then topographic condition, this is very important because normally the land leveling in this drip is even much less than compared to sprinkler. Ups and downs are there, but ultimately when you have a topographic condition is known, then only it is possible to compute your ups and downs and then pressures. Because you have to provide a proper pressure thrust, because the water has to be pushed through right from your fertilizer tank to then filter, then main line, then subline, and then submain, and then laterals, and then nozzles. So the topographic condition is very important information you should get to compute the head drops. Then soil information such as soil information rate, water holding capacity, texture, structure of the soil, and bulk density, like any other irrigation, including in your sprinkler also. All this information is needed. Just you want to how much water depth you want to apply. For example, you can see the sandy soils are there. You can see with less irrigation interval, that means you frequently have to add water. With less drop rate, I mean, dripping drop rate will be less. The discharge rate will be less. Whereas if you heavy soils like clay, you can more drop rate. That means more discharge, but irrigation interval will be large, even 5 days, 10 days, and even more than that sometimes. So this is how the soil information will help you. Similarly, climatic record we have discussed in sprinkler also, how the climatic records help us, how much is evapotranspiration occurring from that region. So that will give you, that's the information which is very much useful here also, and decide the kind of irrigation schedule as well as the depth of water to be applied and so on. So when it comes to basic hydraulics, again these discharge computation and all, already some formula was given earlier, but here the head drop is the one which is very much important in the drip irrigation. So loss of head by friction in a drip irrigation is given by this formula: delta H is equal to 15.27 Q powered 1.852 divided by D into D powered 4.871. This is William has an equation using this C equal to 150. So basically it gives the energy drop by friction, and then what is Q, total discharge in the pipe. Computation of this earlier we have given the formula. Length of the pipe in a particular section. See, you have a main line, each section will have a different discharge, that is there. Then length of the pipe in that section, then inside diameter, all these things we will decide in the design parameters. So this is how the head drop is computed. This equation is used to compute the energy drop of a main line, and of course with some modification for the laterals and even submain and so on. Similar such formulae are available here in the literature to calculate the head drop for each and every component of the drip irrigation. Let us go for the design of this type lateral line design charts for uniform slopes. For non-uniform slopes, one more chart is there. So first of all, let us go to the chart. You can see this chart divided into 4 quadrants. First quadrant, second quadrant, third quadrant, fourth quadrant. Let us go back again. In these quadrants, you can see this is L by H, this is the discharge, and this is the slope. Let us go back to understand step by step. Establish the lateral length L and operating pressure head H ratio L by H and total discharge Q inlet. So length and operating pressure head and its ratio L by H and total discharge Q. These things to be needed. You must know. So then step 2, what is that? Move vertically from L by H to the given total discharge line in quadrant 2. Then establish a horizontal line in quadrant 1. Let us go here. See, you know L by H, length by head, that ratio. Take one value and move to the discharge line. Which discharge line you want to move based on your discharge in that line. So then you extend a horizontal line into this quadrant. Keep that line here. Then what is the next step? determine the submain slope. Sorry. Yeah. Step 3, move horizontally from L by H to the percent slope line in quadrant 4. Then establish a vertical line into quadrant 1. Let us go to here. See, again take this L by H here in this, and then this is, for example, this is your L by H. Move to this quadrant 4 to the required slope line, whatever slope line you have, and then you fix the point and straight away extend that line. So this line and this line will intersect at one point and give you whether your design is correct or not. For example, if your line falls on this is very good, that is acceptable. This one, that is desirable pressure variation less than 20%. So you are good. Otherwise, if it is there, then acceptable pressure variation is 20 to 40%. Not that much good, but it's okay. But if the point falls in this one, that is not acceptable. So this is for 12 mm, and like that different diameter you will have other charts. So let us proceed further. This is a simplified design chart for the submain. So again you will know, you will need to have discharge and L by H ratio. Then let us go. Here you can see this is the discharge, and but pick up your discharge point here and land onto the line belongs to the L by H ratio. Suppose L by H ratio is 20. So suppose your discharge is somewhere around 0.5 liters per second. Then you go on, move up to here, and then read what is the diameter on this scale. So this is the submain design chart. I hope you have followed. Again I repeat, discharge you select, and then for example particular discharge is selected, you move, land on to the L by H line, you have determined for that submain, and according to that point you just select here. Okay, next one, the mainline design. Mainline design, you can see step 1 is plot the mainline profiles and the required pressure for a drip irrigation as shown in the figure. Let us go to that figure. This is the mainline length, and then mainline slopes are plotted, and then its pressures also plotted. Then you extend like this one line energy gradient till it meets this pressure to the top. This is the input pressure you will get. So then you compute this slope delta H by L. Come back to here, because based on the discharge given that delta H by L, and you will decide the diameter. Though like that, in every section you will be computing the discharge, and this discharge is continuously in the main line. This discharge is one section is the next section it is decreasing. So based on that you will be decreasing your diameter also based on this delta H by L of this line slope. Okay, so for every along a main line there will be a decreasing diameters also. So this completes the design of the mainline design, and of course various steps are given here. The same thing what we have explained, and then also submain design, mainline design, submain design, and also lateral design also. So I think we have finished this drip irrigation here. I will stop this video here. Thank you very much.